the limit of a function, but in 1.4 we're gonna actually define what a limit is and take a look at it then more closely. So when we see the notation, the limit, like lim x and then the arrow a, what this is, like, we can read this as the limit as x approaches a of, or the limit, the limit of f at x as x approaches a is equal to L. So L being just a number, okay? It means that the value of f at s can be made arbitrarily close to, say, a, L by choosing x sufficiently close to a, but not equal to a. Okay, so again, when we were talking about that h approaches 0, so sufficiently close to a, but not equal to a. Okay, but the limit as x approaches a of f at x exists if and only if the limited value from the left equals the limited value from the right. Okay, so what this means is if we skip down here, so the limit of f at x as x approaches a equals L if from, do you see this right here, this negative sign? Okay, if from the left-hand side it equals L, and it also equals the same number from the right-hand side. Otherwise, the limit does not exist. What that means is if we have a function and from the left-hand side, so obviously if we're looking at this point here, which we'll call A, if we're looking at the left, we're coming in from the left, and if we're looking from the right, we're coming in from the right. As long as those two approach the same number, then that is our L. That is our limit. Okay, so let's do a little investigation. Okay, so determine the limit of y equals x squared minus 1 as x approaches 2. So we have the 2 right in the middle. Okay, so let's actually sub in 1 to x squared minus 1. So 1 squared minus 1, I get 0. Okay, 1.5 squared minus 1, I get 1.25. 1.9 squared minus 1, I get 2.61. 1.99 squared minus 1, I get 2.9601. 1.999 squared minus 1, I get 2.996001. Okay? Now, let's come into the 2 and let's approach it from the 3. 3 squared minus 1, I get 8. 2.5 squared minus 1, I get 1.25. Oh, sorry, 5.25. Okay, 2.01 squared minus 1, 3.0401. 2.001 squared minus 1, I get 3.004001. Really, really small. Okay, and now at 2, it doesn't even matter at 2 if the limit actually exists. What we're looking for is from the left side, so like the smaller numbers, and from the right side, do these approach the same number? Okay, if you want to put the 2 in, 2 squared is 4 minus 1 is 3. Of course, that's between 2.99 and 3. So coming in from the left-hand side, the limit of f at x, when x approaches 2 from the left, we get 2.990001. And, oh, there's 6. Okay, and the limit as of f at x as x approaches 2 from the right-hand side, we got that 3.004001. Okay, so that approaches, it approaches 3, and this one approaches 3. Since these are, so therefore, since the limit as x approaches 2 from the negative of f at x equals the limit of f at x as x approaches 2 from the positive, and those both equal 3, okay, the limit exists. The limit exists. And the limit is 3. So the limit is 3. Okay, so again, for the limit to exist, it has to approach the same number from the left and the right. Okay, let's look at example 2. So Use the table of values to evaluate the limit as x approaches 1 of x squared minus 1 and then x minus 1. Okay, so let's talk about x approaching 1. So from the left-hand side, let's put 1 in the middle. 1, 2, 3, 4, 5. Let's put 1 in the middle, let's say right here. Okay, so if you think about it, 1 squared minus 1 is 0 over 0. Okay, 0 over 0 does not exist. Like, that's undefined. That doesn't exist. So we actually have to take a look at maybe what approaches 0 from the left. 0.999, 0.99, 0.9, and then maybe 0.5. Okay, and what approaches 1, sorry, from the right, not 0, 1. 1.001, 1.01, 1.1. Let's do 1.5. Forget that. Okay, so if we do 0.5 squared minus 1 divided by 0.5 minus 1, we get 1.5. So let's just basically fill in this chart right now. 0.9 squared minus 1 divided by 0.9 minus 1, I get 1.9. 0.99 squared minus 1 divided by 0.99 minus 1, I get 1.99. I'm going to just guess that this is 1.999. 0.999 squared minus 1 divided by 0.999 minus 1. Wow, I didn't bracket this. Divided by 0.999 minus 1. Okay, 1.999. Beautiful. So this here, we can say the limit as x approaches 1 from the left-hand side of x squared minus 1 over x minus 1 equals, this is approaching 2. Okay, so our question is, does this equal the limit as x approaches 1 from the positive side of this same function? Okay, 1.001 is the exponent 2 minus 1 divided by, okay, I get 2.001. Okay, the next one, 1.01 squared minus 1 divided by 1.01 minus 1, I get 2.01. And I'm guessing that this is 2.1. And then we'll just do 1.5 just to show you guys that it's a little bit different, right? It's still the idea of instantaneous rate of change, but it's going from 2.5 to 2.1 to 2.01. It's getting closer and closer and closer to 2. So yes. Okay, therefore, so even though this number right here does not exist, okay, this is undefined, the limit can still exist. Okay, so therefore, the limit equals 2. And you want to write this sentence right here. Okay, the limit as x approaches 1 from the negative side of f of x equals 2, which equals it from the right-hand side. Okay, the limit equals 2.